Let's determine the rate of growth using the given information. So we are given this growth model, that is a of t equals a naught e raised to the power of kt, and we are also given that the world population in year 2011 is 7 billion, and it adds about 90 million in year 2012. So first, for this problem, we can consider this 1 billion, and this equals, in terms of exponent form, we can write down this as 10 power 9, as well as 1 million. If we write down this in exponent form, we can write down this as 10 power 6. We now consider the year 2011 as the beginning of the year. So that means we can consider that t equal to 0 represents the year 2011. And that means if we plug this into this, we get a of 0, and this equals a naught e raised to the power of k times of t is replaced as 0. So therefore this becomes 0. That is, a of 0 is basically the population in the year t equal to 0, that is in year 2011. So this is 7 billion. So a of 0 equals 7 billion, which I'm going to write down this as 7 times of 10 power 9. Since 1 billion corresponds to 10 power 9, so this is written like this, and on the right side we have a0 e raised to the power of 0. We know that a number raised to the power of 0 is 1, so we can write down this as 1, and a naught times 1 is a naught. So we can determine the value of a naught from this equation, that is a naught equals 7 times of 10 power 9. And this means we can write in this population model as a of t, and this equals a naught, which we now replace it as 7 times of 10 power 9, and this multiplied with e raised to the power of kt. Let's say that this equation is equation number 1, and we utilize the other information, that is the world adds about 90 million in 2012. So let's determine the population in 2012. So population in year 2012, and this equals population in year 2011 plus the additional population which is added in year 2012. And we know that the population in year 2011 is 7 billion, so we write down this as 7 times of 10 power 9, and then the addition population is 90 million, so we can write down this as 90 times of 1 million, we can represent as 10 power 6, as we have already understood. So this equals 10 power 6. So basically this is the population in year 2012. Now using this condition, we can determine this rate of growth. Now let me utilize this equation. So I copy this. This is the current population model. This equals 7 times of 10 power 9 e raised to the power of kt. Now, since year 2012 is 1 year more than 2011, that is, the t corresponds to 1. So, t corresponds to 1 corresponds to the year 2012. So, therefore, if you plug t equal to 1 into this equation, we will get a of 1. So, a of 1 is a population in 2012, which we know that this quantity. So, basically, this a of 1 is this population. So let me plug in t equal to 1 into this population model. So therefore this becomes a of 1, and this equals 7 times of 10 power 9 multiplied by e power k times of, we plug in t equal to 1. So therefore this becomes k times of 1. I'm going to replace a of 1 by this quantity. So it becomes 7 times of 10 power 9 plus 90 times of 10 power 6, and this equals 7 times of 10 power 9. This is a quantity e raised to the power of k. So we can determine the value of k from this equation. First, I'm going to divide both sides by this expression. So when I do that, we divide like this: 7 times of 10 power 9 and 7 times of 10 power 9. So these two expressions or the quantities gets cancelled, and here we will be left with e raised to the power of k. And in fact, this equation can be, or this expression can be rewritten as, let's say this, we consider this as one quantity and this is another expression. So I can rewrite this as 7 times of 10 power 9 divided by 7 times of 10 power 9, plus basically we split the fraction into two parts, and 90 times of 10 power 6 divided by 7 times of 10 power 9. So these two cancel out and giving 1, and we can determine this value. So basically this is equal to 1 plus 90 times of 10 power 6 divided by 7 times of 10 power 9. We can simplify this, and we will plug this value into the calculator. So we get, in fact, before we plug this into the calculator, we can simplify this little bit. So this equals 1 plus, I can cancel this as powers using the power rule. So this is equal to 10 power 3. So it's basically the expression is 90 divided by 7 times of 10 power 3. And we plug this expression into the calculator. So we have e raised to the power of k on the right side. And so we get the value as approximately, so this equals 1.012857, and this is continuous, and we have e raised to the power of k on the right side. Now to solve for k, we have to take natural logarithm on both sides. So basically this equals natural logarithm of 1.012857 continues. This equals natural logarithm of e raised to the power of k. And when we use the power rule of natural logarithm, that is a power property, this k comes in front, and this equals k times of natural logarithm of e. We know that the value of natural logarithm of e equals 1. So this equals k times of 1 equals k. So basically k equals natural logarithm of this quantity. We plug this into the calculator and we get the approximate value of k equals 0.012775. So this k basically determines the rate of growth. We now answer question 72. Here we determine the year such that the population becomes 12 billion as well as 20 billion. So we have already determined the growth rate, that is k is 0.012775, which means we can now rewrite this population model by replacing the k into this equation. So therefore a of t, this equals 7 times of 10 power 9 multiplied by e raised to the power of kt, which is 0.012775 times of t. Now this is the population model which we will utilize to determine the year. And for the part A, we have to determine the year. The population is given as 12 million. That is 12. I'm sorry, it is 12 billion, and this equals. We can rewrite this as 12 times of 10 power 9. So I'm going to plug in uh, 12 times of 10 power 9 is the population for some t, and this equals 7 times of 10 power 9 e raised to the power of 0.012775 t. So using this equation we can determine the t. Let's see how to determine the t. First I divide both sides by this expression. So we will get 12 times of 10 power 9 divided by 7 times of 10 power 9, and this equals e raised to the power of 0.012775 t. And so we can do some cancellation here. This 10 power 9 and 10 power 9 gets cancelled, and finally we are left with 12 by 7. This equals e raised to the power of 0.012775 t. Now, to determine the value of t, we have to apply natural logarithm to both sides. So when you do that, natural logarithm of 12 over 7, and this equals natural logarithm of e raised to the power of 0.012775t. Using the power property of logarithm, we can bring this power in front. So therefore, this becomes natural logarithm of 12 over 7, and this equals 0.012775t times of natural logarithm of e. As we already know that natural logarithm of e equal to 1. So in fact, we can remove this from the equation. So we now solve for t by dividing both sides by this number, that is 0.012775. So therefore, t equals natural logarithm of 12 over 7 over 0.012775. We plug this value into the calculator, and when we do that, we approximately get 42 years. But since we have to determine the year in which the population becomes 12 billion, the initial year is 2011, and we have to add this with the 42. So therefore, we add 2011 with 42, and this gives 2053. So therefore, in year 2053, the population becomes 12 billion. Now let's answer part B. That is, we have to determine the year such that the population becomes 20 billion. So here we can use the same steps. We can just follow the steps, and all that we have to do is we have to replace 12 by 20. So finally, if we keep on doing all these steps, we end up with this expression. So we just have to replace this 12 by 20 and recalculate the t. So let's do that. So I'm going to put t equals natural logarithm of 20 over 7 divided by 0.012775. And when we plug this into the calculator, we get approximately 82 years. We then add this 82 with the beginning of the year, that is 2011. So 2011 plus 82, and this equals year 2093. So in year, this is basically represents year. In year 2093, the population becomes 20 billion.